at day 15. We're halfway through, guys. It's so crazy. I know. I can't even believe that. So for your do now, we just reviewed a little bit of what we did yesterday, where I would give you a parabola and we would just label some of the key features of that parabola. So for number one, I started by giving you kind of a little hint. I wrote some of the, what's it called? The coordinates out for you. I labeled your axis of symmetry. And then the rest of the problems, I wanted you to do those on your own. So for number one, what direction is this opening? Up. Good. What's my vertex?
-3.
Good. To -3. It's that lowermost point, the lowest point here. So to -3. What's my axis of symmetry?
-2.
Yes. X equals 2. We can't just write 2. We're actually writing the equation of a line here. Some of you might remember whenever we would graph lines, if I gave you like x equals 2, that just means no matter what value I have for y, my x is always 2. So it's going to be a line that goes straight up and down at the 2 on the x-axis. So we do need to label it x equals 2. Okay. How about our zeros or our x-intercepts?
0, 0, 4, 0.
Yes. 0, 0. There's our first one. And then 4, 0. What's an x-intercept? Who can tell me that? What does that mean?
It's
Jeremiah?
the points that cross into the x-axis.
I hear a lot of people scrapping. I saw Jeremiah raise his hand, so I'm going to call on him.
Okay, that's where the parabola is actually crossing the x-axis.
Yes, yes. So whenever you hear that word intercept, I always think of it like someone throws you a ball and you are intercepting it. You're kind of catching it, crossing paths with it. You are looking for where that parabola is crossing paths with the x-axis. That's where it intercepts. So we just list those coordinates. And the reason they're called zeros is it's because it's where y equals 0. Whenever our y value is 0, whatever the x value is, that's our x-intercept. What's our y-intercept?
0, 0.
Also 0, 0. So this is one of those cases where we're actually crossing at the same spot for the x-axis and the y-axis, right in the middle. That happens sometimes. Any questions about number one? Okay, let's talk about number 2. What direction is this parabola opening?
Down.
Down. Good. Where's the vertex?
-4, -2, 4.
Okay, so which value comes first?
X.
X. So I want to see where it lines up on the x-axis, right here. -1, -2. So my first value is -2. What's my second value, my y value? 4. 4. Positive 4. It's going up 4. Okay, see that? Okay, so the vertex is -2, positive 4. Okay, what is my axis of symmetry?
X equal -2.
Yes, x equals -2.
Okay.
My axis of symmetry is always just going to be whatever my x value is in my vertex. Vertex falls on that axis. There. X equals -2. How about my zeros?
-4, 0, and 0, 0.
Good. -4, 0. That's this one. That. And then this one also crosses at 0, 0.
I have a question.
Yes.
Does it matter which one goes first? Like, if the 4, 0, and 0 go first over the 0, 0? Or can we just put them in any order?
Like, did you maybe write 0, 0, then -4, 0?
Yeah.
So that's totally okay.
Okay.
Totally fine. In general, whenever we are listing things, we try to keep it from least to greatest. So since -4 is less, that's why I put that one first. But I won't count it wrong because you're still getting the right numbers.
I just did the one closest to the left first.
Yeah, least to greatest, perfect. Okay, how about our y-intercept?
0, 4.
Yeah, same thing again. If we're crossing the y-axis of 0, 0. 0, 0, again. Okay, any questions about number 2?
Ma'am.
Okay, let's flip to the other side and look at 3. This is the one I kind of messed up on a little bit. I was making these really late at night last night. So my right side of my parabola is a little wonky looking, and I forgot to give you a y-intercept point. So I told you to just guess on that one to give me your best estimate of where it might fall. We'll talk about that more when we get there. What direction is this one opening? Up. Good. Where's the vertex?
-1, -4.
Good. -1, -4. I'm going to label it on my graph as well. -1, -4. How about my axis of symmetry?
-1.
Yeah. X equals -1. Right there. Why I'm trying to write negative. There. -1. How about my zeros, my x-intercept?
-4 and 0, 2 and 0.
Good. Here's my first one. -4 in the x direction, and it's 0 in the y. And 2, 0. I'm going to write those in as well. -4, 0, 2, 0. Where's my y-intercept, if we had to guess?
-1 and -4.
So let's look at where this parabola is crossing the y-axis. About in between what two numbers is this parabola touching the y-axis?
-3, -4.
Yeah, it's right somewhere in between -3 and -4. Everybody see that?
I put -4.
So we would guess, I actually drew this a little bit too bowed out. It would probably fall around -3.5, but since I didn't draw it accurately, I'll take anywhere between actually it's 0 first. Sorry guys.
I got -4.
0, -3 to 0, -4.
Great.
Either one is fine with me. So on a graded assignment, I'll always make sure that I'm not giving you something like this. But, this was for participation. Just wanted to see if we could do it, which we did. Wonderful. Any questions about all of these before we go to the review problems? Okay, so let's look at number 4. We're kind of throwing it back here a little bit. We have not talked about factoring in a few days at least. I want you guys to somebody tell me, how do I solve for x here by factoring? What do I need to do first?
Identify A, B, and C.
Yeah, let's identify our A, B, and C. What's my A?
3.
3. B?
-6.
Good. -6. And C?
3.
3. Wonderful.
And then you write your equation. Well, you see, find a common factor, which is 3.
Yes, there's a greatest common
So you
factor.
write your 3 on the outside and put x plus or minus x plus.
Yeah. So here, let's write my greatest common factor is 3. So we're dividing everything by 3. Now 3 goes on the outside of our parentheses. So now we need to figure out our new A, B, and C that goes in the parentheses here.
1, 2, 1.
3 divided by 3 is 1. So I've got x squared here.
Negative.
Yeah, then I've got -2x and 1. Still equals 0. Okay, so how am I going to factor this now? My A equals 1.
Factor to 1.
Skip that whole part.
Did you do the quadratic formula?
I don't know
She
what
still
it
did
is.
it right, I think she didn't write that part out, she just went straight to the.
Oh, I gotcha.
Minus.
I
X minus
gotcha.
and X plus.
So here's where we would find the factors of
Yeah,
C.
because I don't even know what the.
And in this case, our C is what?
One.
1. We only have one option, really. Well, two options if we think about it. What signs do my factors need to have if I have a positive answer? What two numbers?
Or positive, positive.
Yes, either two positives or two negatives. What's my B?
-2.
My B is -2. So I need to find the ones that when I add them together, they add up to -2. That's going to be these. That's going to give us -2. So let's go a little step further here. What is my factored form going to look like?
-1.
Don't forget our GTM. But yes, x minus 1
Okay, so I did do it right. Okay, okay.
and x minus 1 again. Good. And remember, it's still equal to 0. How do we solve for x now? Yeah,
You take.
go ahead.
I was saying, is that what I'm doing on this?
That is what you're doing on this.
Okay.
Totally is.
All right.
So we just got to hear. So if you want to actually kind of tune in, this might be helpful for you.
That's exactly what I just did.
So now that we're here, we have our factored form. How do I solve for x? Jeremiah?
We got to take one of those and write a new equation and make it 0.
Yes. So how would I write that equation?
I would write it as x minus 1 is equal to 0.
Good. We're just taking the values out of the parentheses, x minus 1, and we're just going to set it equal to 0. Now let's solve for x. And guys, if we notice, these are actually exactly the same. So
They'll
we
be the
could
same.
solve it twice, but we're going to get the same answer. We actually only have one x value in this case.
You have to get x by itself, so you add 1 to both sides of the equal sign.
Good. We add
X equals
1.
1.
Yes. And we get x equals 1. That's our answer. That's our answer. So whatever you get as your factors, you just set those equal to 0. Anybody have questions about that process? I know it's been a little bit since we did that.
X minus 1. So if it's a different number, like we'll be solving for both of them separately?
Yes.
Okay.
Yes. So if it was like x minus 1 and x plus 1, then when we solve the first equation, we'll get x equals positive 1. And if this was plus, it's not, but if it was, then we would also get x equals negative 1. So normally we do have two x answers. This time we just have one though. Okay. Any other questions, guys? You ready for number 5? Okay. I need to soundproof these walls. Because I'm always hearing her videos. Okay. Number 5, we want to use the quadratic equation now. Quadratic formula. I said equation, not formula. You all knew what I meant. What's the first thing we should do here?
Identify A, B, and C.
Yes, let's identify your A, B, and C. What's A?
4.
4. What's B? 3. C?
-7.
-7. Okay. So what goes in my first slide?
3.
Yes, 3. And then 3 again. Times 4 times 4. 4.
-7.
-7. All over 2 times
4.
4 times A. Good. Okay. Here's our blank. Here. Okay. So let's start simplifying. Do we need the parentheses right here for the -3?
No.
No.
-3.
Just -3 plus minus
Square root of 3 is 9.
square root of 3 squared, that is 9, correct? Plus
120.
I hear a couple different answers. What is it?
121 when you do the multiplication for all.
Right now, it's what,
So what is -4 times 4 times -7?
112.
112.
Oh, sorry, it's 120 after we add.
Yeah.
Yes, yes. So 112 divided by, what's,
Eight.
yep, 8. Good. So now we can add those together and we'll get 121. So I'm gonna write -3 plus or minus the square root 121 divided by 8. And we could go ahead and do what now?
Break it down, do separate.
Yeah, we could go ahead and separate the equations and do 2 separate ones, but let me check something. Yeah, okay, so I accidentally gave you a perfect square here.
So it's 11.
Yes, the square root of 121 is 11. That was an accident, so we got lucky here. Whenever we're working with like a really crazy long decimal, sometimes it's easier to keep the square root, but if we recognize that we have a perfect square and we're gonna get an even number or a whole number, like 11, it might make more sense to go ahead and solve that out. Up to you, up to you.
A lot of sense.
So I'm gonna go ahead and write 11 instead of radical 121. -3 plus 11 divided by 8 and -3 minus 11 divided by 8. Okay. What is -3 plus 11?
8
8
divided
divided by 8.
1.
1. There's one of our answers. And what about the other?
14 divided by 8.
Very close.
Negative 14.
-14. Yes,
Divided by
-14 divided by 8, which
Negative
is
-1.75.
-1.75. Yes, that is correct. So we got x equals 1 and x equals -1.75. There we go. How are you guys feeling about all these?
Confident.
Good. Yay. Iffy? Better than when we first introduced it? No? Good, good. Hey, I will take that. I'll take that. Awesome. Okay, guys. We're going to talk about a couple of things today.
We're learning something new?
Maybe. Kind of. Kind of. It's kind of new, but not really. Go ahead and get out a piece of paper or your notes, and we're going to take some notes today. And you will have some time to get that ready and get settled. I'm going to title my paper. I got to stay in that habit.
I know we asked this already, but did you ever decide when we're going to have that
So,
quiz?
I'm going to talk to you guys about that today, actually.
Okay.
So before we even take notes, I'm going to show you all something. I like to be very transparent with my students. So here's what's happening. This is the test that was given to me in my curriculum. Okay. I'm not giving this to you.
Anything with fit is X though, right?
Yes, yes. So if it's got like K, that's X, A is X. I'm not giving this to you. What I want to show you is what I'm given and what I'm going to do moving forward to decide when we're taking this. So my thought process and my planning process and deciding what things to teach you, when to teach them, when we're ready for a test or a quiz, is I usually look at the test that I'm given and I see, okay, what do we know how to do already? So these, we're just solving equations by factoring. We learned how to do that. Solving equations with the quadratic formula. We learned how to do that. Find the discriminant. We're going to learn that today. It's not scary, I promise. You actually already know how to do it and you don't even know it. You're going to be like, that's so easy. Promise. Promise. Okay, let's see. More about the discriminant. We're going to talk about that today. Quadratic inequalities. This is the exact same thing as we've been doing. It's just a different symbol instead of an equal sign. It doesn't change much at all. Okay, so that's about where we are. The other things that we've done so far is we've talked about the vertex, we've done the axis of symmetry, we've done the y-intercept, we've done the x-intercepts. These we haven't talked about specifically just yet. The domain and range, we will get there, we will talk about it. We know how to tell if it opens up or down. We can look at the vertex, we can do axis of symmetry. We're pretty much done here. The only things that we haven't talked about is that discriminant, like I said, and you guys don't know it, but you know how to do this already. We need to talk about the different types of equations and what they're used for. The way that I'm going to teach you this is I'm going to just give you the definitions of why each version is good, and I'm going to show you why they're good. I'm probably going to ask you something very similar on your quiz. Why are each version, why are they good for what? So if you keep notes, you will have those answers already. You will have those answers. You can use notes on your quizzes, okay? And I think, I haven't decided yet if I want to put imaginary numbers on this quiz or not. I think I want to save that until after unit 1 because they want us to do imaginary numbers on the first unit, and I just think that we're already learning a lot. I think this is one step too far. But what do you guys think?
I think you're probably right because even though it's pretty simple once you grasp it, I think it's just a bit of fluff, if you will.
I agree. I think that we're already learning a ridiculously large amount of content. It's a lot.
What
So
would I stand for?
Yeah,
Like,
that's not the.
it stands for an imaginary number that doesn't actually exist. We'll get into that.
what is
Not in unit 1 though. We're gonna cut that out of unit 1 and we'll stick it on to unit 2 whenever we get a good grasp of this. Okay. So really all that leaves us left to learn. I'll make you a little list for this whole
That's why he's sitting.
for the whole unit.
He
For the
knows.
whole unit, not algebra 2, just for unit 1. What we are gonna still learn, if you're curious, we are gonna learn the discriminant. And this is not part of your notes today. I'm writing it on sticky note for that reason. Discriminant.
So you think that we'll do the test or like the quiz like after Thanksgiving?
Or before.
I am gonna make it my goal for us to do it probably Monday or Tuesday. And if I feel that we are not all confident yet, we will wait till after. Okay? I don't want anybody to feel like we are in over our head because if I don't feel confident in giving you that information in that short amount of time, we won't do it yet. Okay? So I'm going to keep you guys in the loop as we move forward. I'll let you know by, Wednesday? I'll let you know by tomorrow if we're going to end up doing our quiz Monday or Tuesday. And remember, we do a practice quiz before. You will be completely in the know for what kind of questions will be on it. I will run you through how to do every single thing. You can use it on the quiz. You guys will be prepared. I promise. You will. So, like I said, we got to learn discriminant. We got to learn domain and range. And honestly, I don't think I want to worry about inequalities in this unit. I think it seems kind of out of place for what we're talking about. It doesn't really have anything to do with what we've been talking about for now. So I think these are kind of the two main things other than the different types of formulas that I'm going to be basically giving you a handout on. So honestly, I think we can do that. I think that that's just two little things. So let's start some notes. This is Algebra 2. We are still in Unit 1. Quadratic equations.
You know, 180, 180. This.
So I'm going to address another thing. The way that this curriculum has been written, and when I say curriculum, that just means the plan for how I'm supposed to teach this. The way that it was written is very crammed together. I am spreading it out much more than they want me to. Okay, so I'm really doing my best to make this as not stressful as possible for you guys. If I taught it the way that it was written, I don't think that we would do well. I don't. I think that it's unrealistic what is expected. So it's not that we're making it any less than what we are supposed to do. What we're doing is we're pulling out the important pieces that are the most necessary. And we're not going to leave anything out. We're just kind of rearranging some things where they make a lot more sense. Kind of like how we're not going to do imaginary numbers yet. I don't think it's relevant in this unit just yet. Next unit, we will look at those. Okay, so I'm going to label the day. It's day 15. And this is page 3, because our do now is page 1 and 2. Okay. So I would like for all of you to just write the standard form, is what we call it, of a quadratic equation. And what that is ax squared plus bx good, plus c equals 0. Okay. So we're going to learn how to identify the discriminant. D-I-S-C-R. I'm going to give you a little formula. E stands for discriminant. So in parentheses here, I'm going to write D, so I don't forget. D equals B squared minus 4AC. You guys already know that, don't you? Where does that come from?
Formula.
The quadratic formula. That's what goes under the square root, okay? All we do for the discriminant is grab that part of the formula from under the square root and we figure out what that number is. So I'm going to tell you what the discriminant means after we practice kind of solving it. Let's say I give you 3x squared minus 2x plus 4 equals 0.
-2 squared minus 4.
Yeah, so first let's identify our A, B, and C. Let's identify those. What's our A?
3.
A is 3. What's our B?
-2.
Good. B is -2. And what's our C?
4.
+4. Good. Let me get my orange. There it is.
I'm so hungry.
C equals 4. Girl, me too,
I'm sorry.
honestly.
No.
Okay, so all we gotta do,
You plug it in.
plug it in. Exactly. So,
B equals -2. Oh, so just right like that.
yeah, so I'm actually writing like a fill in the blank thing first. You may not even need to do this, but I am real quick. So in the first parentheses, I'm putting my B. What number do I put?
-2.
Good, -2. After -4, I'm
Do we
putting
do
A. What?
I was gonna ask, is it like the other formula where we change that -4 to a plus and put a -4 on the side?
Yes. So if it has helped you with the quadratic formula to put plus -4 times these numbers, do that same thing here. Do the same thing here.
Sorry.
No, I appreciate you asking that. So I'm gonna write two options then. You can either do b squared minus 4ac, or think of it as b squared plus -4 times a times c. And it all just depends on what kind of number we get. Whatever feels more comfortable for you. These are the exact same thing. They're just written a little differently. So our A goes next. What number do I put here? 3. And then C is what? 4. Good. Okay, so now we need to solve this out.
The right one is 48.
So 4 and -48.
Yeah, so -2 squared is
4
positive 4
plus.
plus or minus. It with
Oh,
depends on
sorry.
which one you're
Yeah.
using. Now you can look ahead and see a negative number times a positive number times a positive number is gonna give us a negative answer.
-48.
Yeah. So we would have plus -48 or 4 minus 48. Okay. Let me use not that ridiculously light purple. I can't even see it. Doubt
It's
you guys.
pretty, but if you
It
can't see
is
it.
pretty, but it's a little tough to read. Sorry, guys.
So B would be -44.
So 4 minus 48. What is that going to give us?
44.
-44.
44. Yes.
So that
So
would be our D.
our discriminant is -44.
Okay.
Yeah. Good. We're going to practice a couple more of these, and then I'm going to tell you what it means. How do we use this? Because right now, discriminant just seems like a random word I made up, and it has no meaning to us.
That's what you add together.
It is exactly what goes under the square root. Let's do one more together real quick. Let's do, let's do 2x squared minus 5x minus 3 equals 0. So, my D, or my discriminant, equals b squared
-5.
minus 4 times a times c. Yes, my b is -5. So we put that in first. And what's my A?
Your A is 2.
Good, my A is 2. And what's my C?
-3.
-3.
2. -3.
Okay. So let's simplify. What is -5 squared?
25.
25. What is -4 times 2 times -3?
24.
Positive or negative?
Positive.
Positive 24.
49.
25 plus 24 is 49. 9. So our discriminant is 49.
That's very simple.
It is very simple. It absolutely is. Feels a little easier after doing like 30 steps further than this. Yeah. Okay. So before I have you guys try some on your own, let's talk about what this means. I'm actually going to start a new page because I want to give myself lots of space to represent what this means. Does anybody still need to see this work? Okay, you can wait. Take your time. Take your time. Pause it real quick, actually. Good. So, if you can fit it all on this page, great for you. I'm going to start a new page because I want to give myself space to draw some pictures because I am a very visual person and that helps me and I think it's going to help you guys too. So this is day 15 continued. Page 4 now. Algebra 2, Unit 1. Okay. So I'm going to rewrite that formula for the discriminant up here just so I can kind of have it tucked away and I can reference it if I need to. So D equals B squared minus 4AC or plus negative 4AC, whichever you prefer. They're the exact same. B squared whatever you prefer are the same. So once we have found our discriminant, once we find those answers, just like we did previously, we found negative 44 and then positive 49. Here's what those numbers are going to tell us. Whenever we get a discriminant that is greater than 0, and somebody tell me, what kind of number does that mean? If I get a number that's bigger than 0, is that a positive number or a negative number? Positive. So sometimes when I'm looking back at notes and I see this symbol, it might throw me off. I'm going to write underneath it when the discriminant is positive. When the positive. That means that we have, right. This means that we have 2 real solutions. I'll tell you what I mean by real solutions. So we touched on just a minute ago, I just showed you what imaginary numbers look like. We weren't learning about them, but I showed them to you. There are imaginary numbers and there are real numbers. Whenever we get a positive answer for the discriminant, that just means whenever we solve for x, we're gonna get two numbers that are real. We're not gonna have imaginary numbers in our answer. That's all that tells us. So, no imaginary numbers. Okay. And then I'm also gonna draw a little picture. This is optional, but I personally find it really helps. What that means is when we have our graph, and this does not have to be accurate at all. Your parabola is going to cross the x-axis in exactly two spots. That's what this means. So two real solutions or two real zeros, two real x-intercepts. Rows. Intercepts. Okay. I'm gonna draw a line. That's all the information about when it's positive. So next, we're going to talk about when the discriminant, or D, is equal to 0. Sometimes we do that, b squared minus 4ac. We find the discriminant, and our answer is just 0. I'll tell you what that means.
One real solution, that's it.
One real solution, yes. So when the discriminant is 0, is exactly 0, not 0.5, when it's 0. When the exactly 0.
It's not like zero, is it? Oh, zero.
No.
We have one real solution. Still no imaginaries, just one real solution. The same thing here. It's also the zeros we're talking about.
Their X's.
Or the, yes, the x's, the x-intercepts. So, fun fact, you don't have to know this, I won't ask you this. But whenever we have a discriminant that is 0 and we only have one solution, we call this a double root. And I'll show you why. When we draw a rough sketch of the graph of what this might look like, our parabola is going to touch the x-axis at exactly one spot, just one. It's going to be kind of like this. Just one. So if I'm not incorrect, I think that our do now problem would be like this. The one where we factored for the zeros
Yeah,
and we got x minus 1 and x minus 1. We only had one real solution there. We had x equals 1 because those are the same. So I believe you. And I hear you saying, yeah, so I'm probably right because I know you know it, Jeremiah. I believe that's going to be a case where we have a parabola that just touches it once on the x-axis, just like that. So I bet if we tried using the discriminant formula for that equation, we would get 0. Now, I don't want to falsely say that this one has no imaginary numbers. I want to ask Jeremiah, do you know if this means that there's for sure no imaginary numbers? Or is it
No.
possible?
that, that's a great question. I'm not completely sure.
Okay, I'm not completely sure either. I would need to look into this.
I
So-
think if we were to look at French mathematics, they would say
Yeah.
yes,
Okay,
but I don't think so. I
right.
don't. But the
Is
French are
math not
funny.
the same around the world?
They have some little differences here and there. Like in French math, 0 is considered both a positive and a negative number.
Interesting.
Math is considered a universal language.
Yeah, to an extent it is. To an extent. There's all sorts of different math things. Pretty interesting. Kind of like how, not exactly the same concept, but we use the, what's it called? Other countries measure things in metric, and we use, what's it?
Imperial.
Imperial. I should know that. Okay, so that is what happens whenever our discriminant is 0. Now we need to talk about when it's less than 1. This is where we get funky answers.
The discriminant is 0, by the way.
It is? Did you try it out?
Yeah.
Awesome. That's really cool. I didn't even mean to give you one like that, but pretty fitting for today. Okay. Now we have D is less than 0. What kind of number is less than 0? Negative. So when the discriminant is negative, you guys notice I have intentionally for the last few days only given you equations where you'll get a positive number under the square root. That was on purpose. If you get a negative number under a square root, that's how imaginary numbers exist. You cannot find the square root of a negative number. It doesn't exist. So that's why we call them imaginary numbers. I'm going to label this again. When the discriminant is negative. And in this case, we're going to have 2 imaginary solutions.
Meaning there's no real root.
Yes, meaning there's no real root. Okay, and so let's add another little part to this. I'm going to pull that down just a little. I'm actually glad that you said root because I think that might help it make sense to some people. Whenever we find the square root there, these numbers that we find are x values. We also call these roots. So we could say here, that we have 2 roots in the first one when our discriminant is positive. When our discriminant equals 0, we have 1 root. And then we're going to draw the picture for the last one and show why there will be no real roots. So let's start with a rough sketch of a graph. And when we have imaginary solutions, when our discriminant is negative and there are no real roots, our parabola is not going to be touching the x-axis. It's just going to be somewhere like that. So we would say no real root. Like that.
And you said that's when the parabola is not touching the x line.
Yes, yes. So in this case, whenever our discriminant is a negative number, we have no x-intercepts. You're gonna not touch the x-axis at all. It'll be floating above, or I believe it could also be floating below it. Pull this to the side. We have 5 minutes till lunch. I'm gonna let you guys go ahead early. Enjoy some lunch. When you guys get back, we are gonna practice finding the discriminant, and deciding what that's gonna tell us about our graph. Enjoy your lunch. Finish these notes up if you're not done, and I will see you after lunch.
I'm gonna tell you when I get back, I'm gonna.
Okay, so we're back from lunch. Let's put this guide to use. I'm gonna start a new page. And since we're looking at graphs now, instead of setting my equation to 0, I'm gonna start my equations with y equals. And I'll show you what I mean by that. 5, 8, this is that. Okay. So here is an example of what I would ask you. So if I were to give you y equals 4x squared plus 2x plus 1, the directions might say find the discriminant and determine the number of real solutions. So let's do this one together.
One second, please.
Take your time. Take your time. Gave you a lot of words to write. Write out the discriminant formula again, just to remind us.
It's kind of sticking to my head now.
Good.
That other formula made me remember. I
Right?
just didn't know the song that you were singing that one day.
Yes, or Pop Goes the Weasel. Y'all want me to sing it again?
Yeah.
Please.
Little performance. Okay, so I'm gonna have you guys repeat after me. I'm like throwing it back to my music days. So I'm gonna start and you guys echo me. X equals negative b.
X equals negative b.
Plus or minus the square root
Plus or minus the square root
of b squared minus 4ac.
of b squared minus 4ac.
All over 2a.
All over 2a.
That was good.
You guys have the best harmony.
Aw, that was cute, you guys. That was adorable. Okay, so we can do some more of that later on. Let's work on the discriminant though.
Yes, more music class.
Yeah.
Let's become a music group.
I'll bring my my guitar in next time. All right. So, what's the first thing we need to do here?
Identify your A, B, and C.
Yes. Identify A, B, and C. What's our A?
Your A is 4.
Good. 4. What's our B?
2.
2. And what's C?
1.
Good. 1. Okay. Let's plug those numbers in.
B equals
So I have B equals
2.
good. 2 squared minus
4.
4.
Can I ask a question?
Yes, please.
What are we adding up?
What are we adding up?
Yeah, are we just, like, what are we doing?
So we are finding the discriminant
Right.
of this equation. And what we're going to do once we find that answer is we're going to use this chart that we just made and see if our answer is a positive number, then we say that there are 2 real solutions. If it's equal to 0, there's 1 solution. If it's a negative number, there's no real solutions.
Right. I'm talking about, like, how did you get 2 squared and minus 4?
Okay. So we're just using the formula.
The
D
plug in.
equals B squared. D equals, our B is 2. So I put 2 in there. Here, maybe this would help.
Okay.
I'm
I thought we
filling
were, like,
in.
adding something together, so I'm like,
No,
how are you
no.
getting this? But, okay,
No, I'm
thanks.
glad you asked. Yeah,
Wait.
we're just plugging in the formula. Yes.
So when we plug it in, I'm gonna let you go ahead and do that. So then I can go as well.
Okay, sure. All right, so what comes next in the A spot?
4.
4. And then we gotta multiply by C as well, which is
1.
1. Okay, go ahead, Elisa.
So then after we do all of that, are we doing -4 or -4 times 4 times 1?
Yes.
Yeah.
So we're doing whatever 2 squared is. And you could think of it like this. You could think of it as minus 4 times 1. Or you could think of it as times -4 times +4 times 1. And I'll show you how those will give us the same answer. Let me write it out separately to show you, I guess, the difference. I'll show you both of the ways.
Basically, you figure out the left side, then you figure out the right side and add them both together.
Yeah.
Or give you the discriminant.
Okay, so let's do it this way first, since we've been doing our quadratic formula this way. We're gonna do plus -4 times 4 times 1.
So the addition is basically like imaginary.
No.
So what's happening here
Like,
is we know from our basic math rules, and maybe we don't know, let's remind ourselves. Whenever we add a negative number, it's the same thing as subtracting. We're really subtracting whatever this answer is from whatever this answer is.
So the census would be D equals,
-12.
negative,
Yes.
I don't know how to, can you say it?
The derivative or discriminant,
like how
not
you would
derivative,
say-
my bad, discriminant.
Like, if we were to put that in the calculator, how would we say it as a sentence?
Okay, here.
I think that's where we're all confused, like, we're not knowing what
Okay.
we're supposed to do after the 2 squared.
Okay, so here, let's do it all together. First, what is 2 squared?
4.
4. Okay, so I'm gonna cross that off,
Plus.
and I'm gonna do it to both of these. 4. So we could either think of it as minus 4 times 1, or plus -4 times 4 times 1. I think this will make more sense when we see the answer written out and we show how they're the same.
4
So
plus
let's-
-4 times 1. And I get -16.
So
Right
negative
here?
Yeah.
Yeah.
Okay, so yes, when you do,
Times 4 times
oh,
1.
you're okay. You're okay, go ahead. So whenever we do plus -4 times 4 times 1, we're gonna get 4 plus -16. When we do the first option here I was showing you, 4 times 4 times 1 is positive 16. So we're gonna have 4 minus 16. So 4 minus 16 is the same thing as 4 plus -16. So the reason it made more sense for us to do plus when we were doing the quadratic formula previously is because I was making it so our answer would always be a positive number. Now we might have some negative numbers. So in the long run, not making it the plus might make it a little bit less confusing because then I don't have to think about which do I get rid of, the plus sign or the negative or the minus sign.
What
Like,
I do,
I would
that
think
makes
of
the
it
most
as
sense to me,
yes,
is I treat the b squared as one operation,
yes,
and then I treat the -4 times AC as a separate operation.
yeah,
Yeah.
So then whatever answer you get as a negative answer, it's minus that, and
Yeah.
the positive answer, it's plus.
that's a great way
That
to
works
think of
better for
it.
me.
That's a great way to think of it.
That's right.
Okay, so, yeah. The way that you're doing it, Kelly, it's like we're just not worrying about the minus or the plus.
Yeah,
We're just thinking of it as
we're
negative
just treating it
4.
as a -4.
Yes. Okay. Who is anybody lost right now? If you are, tell me. We can. I want to maybe
Okay, so
unwrap
what if
this
we get
mess.
a negative, say the equation was y equals -4x.
Okay. Let's try that. Well, first let's solve this out, and then we'll do that next.
Okay.
Okay. So what is 4 minus 16?
-12.
Good. D equals -12. If I did 4 plus -16, I'm also going to get -12. Same answer, just a different way of writing it. So when we find that our discriminant
It's negative.
is negative or less than 0, how many real solutions will there be? None. There's 2 imaginary solutions, but there are no real solutions. So our discriminant is -12. We would say no real solution.
So that's what we would write on the test.
Yes, and I will ask you for that specifically. I'll say
Okay.
how many real solutions. Okay. Now let's do,
So everything that is a negative is a no real solution.
yes,
Okay.
yes, your discriminant has to be positive to have 2. Your discriminant is 0 to have 1. Like that part. If it's positive, we got 2 solutions. If it's 0, we have 1. If it's negative, only imaginary. Or we could even write here, no real solutions. So if you want to add that to this little chart we made, that might be helpful. No real solutions whenever our discriminant is negative. There are no real solutions. I should have led off with that. It makes a lot more sense to say that way. Okay. Can I move this or anybody still need it? Happy to keep it up? Happy to move? Okay, let's try the negative A and see what happens. So for the next example, we'll do y equals -3x squared plus 4x plus 7. Okay, so again, find discriminant and determine the number real solutions. Discriminant D squared or so what's our values for A, B, and C?
3, 4, -3.
Good.
And 7.
-3, +4, and +7. Okay. So we will need to plug this into our formula now. So we have B equals
4 squared.
the 4 squared. Negative 4 times -3 from A
Then 7.
and 7. Okay. So what is 4 squared?
16.
16. What is -4 times -3 times 7?
84.
I
Wait,
haven't checked. Let me look.
Oh, it's 84.
I
is
bet
it?
y'all are right.
Okay, it scared me.
-4 times -3 times 7. Yep, I got +84. So do we put +84 or -84?
Plus.
Plus. I really like that method, Kelly. I think that's gonna be helpful. Appreciate you sharing that.
Since I know I'm doing plus or minus last.
Right.
Pretend the
So
minus
it's
sign
like-
doesn't exist really.
So what you basically said, because I wasn't actually listening when you said no trying to think. So basically, you have your formula. So what you're gonna do is you're gonna treat this like that, and sorry, include the negative in.
Kelly, in a minute, do you think you could actually come and show that on the screen so everybody can see? Because I think that would really help
We need to on
everyone.
YouTube.
Yeah, you'll be up on YouTube. Kelly's gonna be famous.
So whatever our last answer is, like that would be like negative or positive.
So it has 2 real solutions? Okay, go ahead.
Yeah, so here, before we do find out, Kelly, could you come up and show? Would you like to? All dressed up today anyway. So warm up for the presentation, or did you already have it?
I haven't had it
No.
yet.
Oh,
Next
okay.
period.
All right, so teach us about what you were just telling, Elisa, and you can, cover mine up if you need. Feel free to move the camera if you
You
need.
don't have to divide it.
Okay, so
You know, do 1/4.
All right, everybody listen to Kelly.
We have -3 -3x squared x plus 7. And then we have, we're gonna plug in with our, formula. So D equals 4 squared. So this is kind of like one part of your problem. And then your next part would be the -4 times
-3.
-3 times +7 times 7, and that's all together. So you do this, and then since you end up with a positive answer here, you do a plus sign. But if you ended up with a negative, you do a minus sign. So you can just not really worry about it, just treat it as a -4 instead of worrying about your plus minus until you have your solution from your.
That's what I
From the
did.
second operation,
Yeah,
yeah.
I separated also, like,
Yeah.
I just do the
That makes
first
a lot
part,
of
second part,
sense.
and add them together.
Yeah.
Sure.
Because
Right.
then based on, what you get here, I got positive 84, so it's gonna be
Just
plus
like how we used
84.
to do with at the beginning, when we,
I
never
like
mind, don't worry
it.
about it. That's a couple weeks
Yeah.
ago.
Awesome. Thank you,
Thank
Kelly.
you.
I appreciate you showing us that. That's very helpful, seriously. So if you wanted to do it the way she just showed us, you could just use your grouping symbols a little differently, kind of like that.
So that they know to group it together.
Yeah, that way you know you're gonna do 4 squared as one part. And then we're gonna do -4 times -3 times 7 as another part.
And add or subtract.
Yeah, awesome.
Should I be two real solutions?
Yep.
Yes,
You're so-
so what's 16 plus 84?
100.
Good, 100 is the discriminant. And because our discriminant is greater than 0, there's 2 real solutions. So that would be our answer, 2 real solutions. Circle that. Awesome.
Okay, can we do one more?
Yes, yes. Oh, here, yeah, I'll wait. Sorry, guys, I'm kind of speeding. And I'm gonna write out a bunch of practice problems for you guys so that you can try a bunch of
Oh,
them
if
on
we're
your
going
own
next
as well.
problem, I don't need it unless somebody else wants to.
Say that one more time.
One more. Never mind, one more.
Okay. Okay. Anybody still need this or can I move it? Okay, thank you. Thank you. I can wait. No problem. Hope I'm recording. Okay. Sometimes I wonder. That happened in one of my classes the other day. We had gotten so far and I didn't record any of it. But that's all right.
And this doesn't really, you don't need to do a lot of work for the.
Yeah, these don't take as much work, thankfully. They're just,
Will we be graphing with this or not?
Not with just the discriminant. The discriminant's gonna tell us, kind of help us confirm if our graph is correct in the future. But, it won't tell us where the solutions are on the graph. It's just telling us how many we have. So we can't draw a graph from just the discriminant. It does tell us, though, how many times we're gonna cross the x-axis. Okay. Everybody got it now? Okay, I'm gonna give you a few more. Okay. Let's see. And this is page 6 now. Here's some practice problems. The directions at the top. So find the remnant each quadratic and determine number.
Is this the exercise or?
This is practice.
Okay.
Our exit ticket will probably have something like this on it. But this isn't an exit ticket just yet. Okay. 1, 4, 5x squared plus 4x minus 3 And does anyone still want us to run through one more together, or you guys feel good? Okay, few people, so let's definitely do one more together. If you already feel good, you're welcome to start trying these on your own. But let's definitely give a little practice together for everybody else. Let's do number one together. Again, if you want to go ahead and do it on your own, that is totally fine with me. Let's do one more though for good measure. So first I'm going to write out the discriminant formula just to the side to remind us what it is. Discriminant equals b squared. I'm going to use those grouping symbols that Kelly showed us. I really like that. Minus 4. For number one, bless you.
Thank you.
What's the first thing we should do?
On the A, B, and C.
Yes, let's find our A, B, and C. I'm gonna write A, B, C. And what are those values gonna be?
-5,
Mhm.
4, and -3.
Perfect. -5, 4, and -3. So what do I do with those numbers now?
Put them in the formula.
Put them in formula. B equals
-4.
-4.
4.
Yes, 4
Okay.
squared. Perfect. -4.
-4.
Mhm.
I mean,
-4 minus 4, either one works.
times A, so -5.
Perfect. 5.
Times C, -3.
Good. C, -3. Got all that right now. What do I do next?
Plug it in.
Yeah, so we've got our numbers plugged in.
Oh, find the square root of 4,
Yeah.
16.
So the squared for 4 squared, 16. Perfect.
How do you find the square root of 4?
The number times itself.
So you can either do 4 times 4, or
Never mind.
you can type it in your calculator like this. So this will be a good reminder for anyone that does forget. 4, and then your square button is right here across from the 7. It just looks like x squared. I push that and you'll see a little 2 appear. I hit enter and I get 16. All right.
But if you do a negative number square, it's not right on.
Yes, it will be wrong if you don't type the parentheses in. So if I write -4 squared, it's going to tell me the wrong answer. It's telling me -16. I need to put parentheses first if I have a negative number.
See, okay, I didn't know that.
Yes. Very important.
Then we could do -4 times -5 times -6.
Yes. -4 times -5 times -3.
-60.
Yes, perfect. So do I write plus 60?
Minus.
Yep, -60. Good. Okay, so what's my next step?
16 subtract 60.
Good. 16 subtract 60, and that's going to give me
-44.
-44.
And that's no real solution.
No real solutions. Yes, we need it to have a positive number or a 0. And since it's negative, no real solutions. Very nice, you guys. Bless you.
Bless you.
For a
Thank
second,
you.
I was confused, but I realized that I added 16 and 60 and didn't subtract them.
I
It got a different
gotcha.
ending.
Yeah, those signs are really tricky sometimes. It's so easy to make that little mistake. Okay, so there's number one. I want you guys to try the rest on your own. I'm gonna pause the recording, set a little timer, and we'll come back together and check these together. Unpause. Here we go. All right.
And looking at this and make it choose.
Let's look at number 2 together. What's our first step?
Identify A, B,
And
C.
then.
Say it one more time.
Identify A, B, and C.
Yes. Let's figure out our A, B, and C. What's A?
10,
10. What's B?
-7,
Good. -7. And C is
2.
2. Okay, so we're gonna write D equals, what are we squaring?
-7.
Good. Our B is -7 squared minus 4 times
10.
10 times
2.
2. Okay. What is -7 squared? 49. Good. D, 49. And how about -4 times 10 times 2?
-40 times 2.
Yes. -80. So -80. 49 minus 80.
-31.
-31. That's our discriminant.
No real solution.
No real solutions. Good.
Oh,
Alright, SLN. No real solutions. Okay. Number 3. Our A.
-6.
Good. What's our B?
-3.
-3. What's our C?
-9.
-9. So let's plug those values in. What number are we squaring?
-3.
Good. -3 squared.
-4.
Mhm.
-6.
-6. -9. Okay. So, what's -3 squared? 9. Good. -4 times -6 times -9.
-216.
Woo! Good number. -216. What is that going to give us when we subtract?
-207.
-207. Good. Solutions?
Nope.
No real solutions. Good. And please stop me if you have any questions along the way. Okay, number 4. What's our A? 2. What's our B? 4. What's our C?
-4.
Good. Plug them in. D equals -4 squared.
-4
Mm-hmm.
times 2 is -12.
-12. Okay. So -4 squared.
16.
16. And -4 times 2 times -12.
96.
Good. Plus 96. What's 16 plus 96?
112.
112. Good. How many solutions?
2.
2 real solutions. Good. You got that? Okay, the last one. Is, okay, our B is, and our C, 1. So, what are we squaring?
15.
15 squared And then -4 times -11, good, times 1. 15 squared, that's gonna be big.
25.
325, 225, thank you. 225. And what do we get for? Yes, plus 44. 269?
Yep.
Real solution. 2 real solutions.
Oh, I got one wrong. That was number 3, but it was because I didn't put the negative.
Gotcha. Hey, only getting one, that's awesome. That's wonderful. First day learning this. How do we feel about this, guys?
I feel
Not
good.
confident.
Um,
I'm not confident.
You're not confident? Which
I
part?
keep like messing up my signs,
Mm.
like when it comes to the, after like, doing the first part. I don't know
Okay.
why, I keep confusing my signs and like either subtracting them or like I have a negative in front of one. I don't know.
Okay, so are you confusing the signs whenever you're plugging them in or whenever you're solving? Woo! Bless you.
I think whenever I'm solving is when I'm
I did.
like,
Okay, whenever you're solving.
Yeah.
Took my purse.
So I think sometimes it's really easy to make mistakes with signs when we're doing all 3 numbers multiplied at once. I wonder if it would help to do the first 2 first. You know, we do -4 times -11. And then a negative times a negative is a positive. That would give us positive 44. And then do the times 1, which won't change it.
I think of it this way, if it's only one negative sign out
Yeah, I
of
think
3, I
maybe-
know that it's gonna be a positive.
Yeah,
yeah, I
okay.
think maybe that's what I'm getting
If it's 2 negatives.
confused and what I'm
Right.
I
doing.
mean,
Like doing it all at once rather than step by
Yeah.
step. So breaking it, if you need to break it down into smaller portions, do that. That can be so helpful. And another thing, kind of like what Mac was just saying, here's a little rule for multiplying negatives. Whenever we have 2 negatives, it makes a positive. So when we have an even number of negatives, like when we have 2 negatives and a positive, our answer is going to be positive. If we have an odd number of negatives, we're going to get a negative answer. So like in the first question, we have 1, 2, 3 negatives. That's an odd number. We're going to get -60. In number 2, we have only 1 negative. That's an odd number, -80. 3 negatives, that's odd, -216. 2 negatives, that's even. We get a positive. Yes, Chance?
This is in the slide, but in exponents, isn't it also the same in that evens are the negative exponents when they're even are positive, but odd negatives whenever there are odd exponents?
I believe that you are correct.
Yeah.
I want to say yes, that you are
Okay,
right when
never
you
mind.
say that.
I'm sorry, I completely missed the question.
Yeah, so like -5 to the power of 5 would be a negative, but
Oh,
negative
yes.
That's right, so
Yes.
if it's even power, it will always be a positive. If it's an odd power, it can be either positive or negative. It stays
Yeah.
the same.
So that's why whenever we are doing the squared part first, it doesn't matter if we start with a negative number or a positive number. We're always going to get a positive answer because we're just doing a negative number times itself. So 2 negatives multiplied, which is an even number of
Yeah.
negatives.
So whenever I put them in the calculator, I don't put the negative at all.
Yes,
because know it's
that's
gonna be
kind of
positive.
the shortcut. Instead of having to type out the parentheses, anytime you square a number, it's gonna be positive. You don't even really have to type the negative in.
yeah.
Okay. That is discriminants, you guys.
That was a good deal.
Is this
Yeah.
y'all? I feel good. That's good.
Is this gonna be our exit?
I hope not.
We're gonna have an exit ticket, and I'm gonna give it to you right now.
Good, because I didn't even do that one by accident.
And if anybody
got
needs to see this, the rest of the work, just let me know, and I can show it to you.
All right, I think I'm ready for the presentation.
So, today is day 15.
I'm ready.
Calm down, Jimmy, calm down.
All right, Marie.
So I'm not sure it's a lot.
Okay, and it is November 20th. And honestly, guys, I think this might be helpful for everyone. I'm gonna start writing the due dates on here. So normally our exit tickets are due 1 week after I assign them. However, next week we only have school Monday and Tuesday. Okay, so our due date, yes, that's it. Then we got fall break. Thanksgiving break. So instead of this being next Wednesday, y'all won't be here next Wednesday.
Okay.
It's due next Tuesday.
Oh, that's, yeah.
So this is due Tuesday, November 25th.
So just a day ahead. Just a day
Yes,
before.
on the last day before Thanksgiving. You're obviously welcome to turn it in sooner than that. This is just the last day I'll accept it.
I'm scared. Okay.
Saying that.
All right. So,
For English,
Yeah,
fine.
my spirit's up. She dropped that on the phone. She was looking up at us. He said she was.
I can't talk if you front of you. That's what I said. I did my part on the song.
No, I said you didn't want to say we gotta do that stuff. So.
I'm down there looking at this.
Yeah, I'm down there looking at her. Oh, Lord.
Then you're gonna determine how many real solutions there are.
We was doing the same thing.
Same thing we just did.
I think I did it.
Yeah, that's not.
I'm gonna give you 2 problems today. Just
That's
2.
it?
Just 2.
Hey.
That's it.
Sorry, y'all.
Now, I'm gonna take it a little easy because we're gonna try to learn the last thing tomorrow. And I'm gonna work on making your practice quiz tonight. And if we are able to cover everything, hopefully we can do the practice quiz tomorrow. And give you guys the opportunity to either take your quiz Monday or Tuesday. That's what my plan is for now. And I will keep you in the loop. If it doesn't happen tomorrow, then obviously we'll push it further. But my goal is for us to do it tomorrow. The practice quiz, not the quiz. Okay, just those 2. That is it. Recording.